Okay, this is Toriada, JAXA, Curation, and I think my talk is just out of focus from the Pressurized Rover, but today I'll present about the preparation of our Artemis sample curation, including Cryo-Sample in JAXA. Next, please. In the Artemis 3 and after missions, NASA plans to land the Lunar Polar South Pole region and return sample from its permanently shaded region. And it is reported that the volatile components like H2O, H2S, NH3, SO2, and C2H4 and CO2 were detected in the PSR by the Air-Cross Impact Experiment. So the NASA starts preparation for the curation of the Artemis-Returned sample, including such volatile components. JAXA, as an international partner of the Artemis mission, start preparation for curation of the Artemis-Returned sample, including such volatiles as well. Next, please. JAXA conducts a sample curation for the asteroids returned samples such as Hayabusa and Hayabusa 2. Especially Hayabusa 2 plays a pivotal role in JAXA's future sample return missions. JAXA is now facing the upcoming sample return mission aligned in the next decades, such as MMX, its first sample return from the Mars system, Artemis, and cometary sample return. There are technical challenges to return and curate the cryo sample, achieving the planetary protection. And JAXA has led an international collaboration about sample sharing, data training, and curator exchange. Next, please. As focused on Hayabusa 2, JAXA curation plays an important role to conduct the basic characterization of the unprocessed bulk samples before separation. We have conducted non-destructive observation with non-exposure to the environment. Hydro-2 samples were measured with two remote sensing instruments, Micromega, an infrared spectroscopic imager developed by the IAS France, and ONCT, a visible multiband camera developed by University of Tokyo, Japan. Hayabusa 2 samples have been distributed to initial analysis team and the international AO while maintaining the scientific integrity. Next, please. For Artemis-Returned sample, its curation is defined in the Artemis 3 scientific definition report that the goal of the Artemis curation is to enable the sample science investigation needed to accomplish the Artemis science objectives and to preserve the Artemis sample return sample for future science to the greatest extent possible. And as the Artemis scientific objective 2 is defined that understand the character on the origin of lunar polar volatiles. Next, please. In detail, 5 scientific goals are defined in there in order to determine the compositional state, which means elemental, isotopic, and mineralogic, and the compositional distribution for lateral and with depths of the volatile components in lunar polar regions, and to determine the sources of the lunar polar volatile deposit, and to understand the transportation, retention, alteration, and loss processes that operate volatile materials near and at permanently shaded lunar regions, and to understand the rigorous modification processes, including space weathering, particularly the position of volatile materials in the near surface, and to understand the impact of exploration on the lunar volatile recorded across the surface. Next, please. And thus, therefore, what is necessary to curate the Artemis sample return sample is to handle the return samples from lunar source pole PSR and preserve them with minimal sample alteration, and to describe the return sample with analytical instrument of physical, chemical, spectral properties with minimal alteration, and to create the Artemis sample catalog, including initial description data, in order to distribute the sample for further detailed analysis and or engineering applications, and to control and minimize and monitor the terrestrial contamination to the Artemis sample to make it possible to track back alteration processes after the recovery if it is happened. Next, please. In order to curate the Artemis sample, including such volatiles, we must make clear the temperature condition of the lunar volatiles. The lowest vaporization temperature of the volatile molecules in the PSR sample is minus 103.7 degrees C of the C2H4 ethylene. However, eutectic temperature of the ice in that other volatile phase is much lower than that, such as minus 180 degrees C in the H2O and H3 phase diagram, showing the right figure. And so the Artemis-Returned sample should be treated and preserved in the lower than minus 180 degrees C of nitrogen and a vacuum condition in order to retain their original condition. However, the temperature to handle them depends on what kind of science they plan to be studied. Next, please. So, here I show you a primitive conceptual model of the Artemis sample creation facility. It consists of the normal clean room and of ambient temperature, the cold clean room of minus 20 degrees C. The glow box are installed in the both clean rooms, and the cold glow box is connected to the cryo storage of lower than minus 180 degrees C. Yeah, I summarize my talk. Next, please. This is summary. And after the success of curation of the asteroidal sample return sample, JAXA starts preparation for curation of Artemis returned sample from the PSR in the lunar South Pole. Based on the Artemis scientific objectives, the Artemis sample should be handled, described, and preserved with minimal alteration after their recovery, which should be lower than 180 degrees C in temperature. JAXA curation team starts considering the conceptual model of Artemis sample curation facility, including cryo-samples, to fulfill the Artemis scientific and engineering objectives. Thank you very much for your attention.